And so before I go to the demo, I'll try to set up the context here and the challenge which organizations generally face when it comes to cloud builds, and how they overcome it, and how they overcome the challenge, and how this agent will help in that process. And yeah, so before starting, maybe like how many of you use public cloud directly, like AWS, Azure, GCP? Okay, so pretty much everyone, all right. So in the, like, as you know, like each one of us our own inclination towards one or the other cloud provider, and each one of us have our own favorites there, like based on the kinds of services they provide. But one thing which we might agree, or most of us agrees, is on the surprises which we may get from the bill, right? And some, even the experienced ones or even the novice ones, like sometimes there will be spike in the bill which you even can't explain like why it happened, right? So that's a bigger challenge for the larger organizations too, actually. And they try to overcome this challenge by following some practices called FinOps practices, basically. And FinOps practices have many things like reporting, forecasting, and optimizing. In this demo, we will be discussing about an practice called standardization, which is a FinOps practice which organizations generally follow. And yeah, so let me just jump into the demo part. And for this demo, we'll be assuming like there is a company called TechCorp, which has an AWS account, multiple AWS accounts, and they do have an FinOps team, which has set up the standardization principles. So what does this standardization mean? For suppose on the compute side, they have policies like in the dev and QA side, they can only create certain type of resources, certain type of servers, which are of the lower configuration, while on the production they are allowed to do some higher configuration servers. Similarly, on the database side, they have a policy like they can only use PostgreSQL or any open source SQL, while on the production side they are allowed to do Oracle. So all these are like principles which are part of the standardization principles which help companies to predict the cost. Basically, by standardizing, they can control the cost. And similarly, they have a policy for lifecycle S3 lifecycle. Storage lifecycle also, where the data in the volumes have to be retained to only certain period of time, because beyond that, it's again waste of money. Like once the compliance period is over, there is no point in retaining those data. So all these are like certain standardization principles which we have defined as part of this organization, TechCorp, and I have documented them in the PDF. Here I have used PDF for the demo, but in real time, it can be a Confluence page or any internal knowledge base which the company has, where the FinOps team define these things. And also very important thing is tagging, generally which we do in public cloud, where as you know, like in an organization, multiple teams use cloud, same accounts, and they do a lot of resource sharing. So this tagging will help to track back the which business unit has created those resources for the billing purposes. So all these principles, standardization principles, are documented, and the how these principles are used is like these are the recommendations given to all the developers or the operations engineer to follow when they are preparing their infrastructure as code while deploying the resources. Infrastructure as code, like people who are not using cloud, is a kind of an declarative language which will help you to create resources like through code, basically. Like instead of doing clicks in the cloud, you can use YAML, JSON, or the HCL language based on the like infrastructure as code language which you choose. It can be Terraform. If it is AWS, it can be what we call CloudFormation template. In Azure, it's called ARM. So based on the choice, you will use the declarative language and define the code to deploy the resources. So now we have an imaginary company for this demo, the TechCorp, where we have defined all the standardizations as part of the FinOps practice. Now let's go to the demo part, like how this will help the organization to save the money. So yeah. So I have developed this agent in Na10, which is a low-code, no-code tool, as you know. And the input for this, this agent input will be through chat. The trigger will happen through chat. So here the input, the expected input is the Terraform code, which is developed by the developers before they deploy the resources. And the agent has an OpenAI chat model access for reasoning, and also it has access to Pinecone vector store, where I have embedded the text document which I showed you before for the standardization, right? The policies where were defined. So that data was embedded into this Pinecone vector store, and it also has an embedding OpenAI model. So the reason for this Pinecone vector store and this embedding OpenAI model is we are trying to use retrieval augmented generation here, where we are giving access to our internal company knowledge base for this agent, so that it starts acting as an my FinOps team member or FinOps agent to give recommendations to the developers. So there is a separate workflow where I have vectorized the data and like got it indexed into the Pinecone vector store. I'll show it after this demo part. So for the demo, I'll open the chat, and I already have some code ready where I'm trying to create an S3 bucket, which is nothing but a blob storage in the cloud. So I'll copy this code. So if you see, I'm trying to create a resource bucket called TechOp QA logs, and it has tags, but I willfully I avoided the lifecycle policies here. So let us see, like if I pass on this code to the agent, how it would respond. I'm giving it the same code in the message. It's there no other prompt, it's just straight away code. So it triggers the agent. You can see the flow actually, like in the init, and it clearly shows the step-by-step process. Yeah, the workflow executed successfully, and now I got a feedback. Let me make it much more bigger. So in the feedback, I don't know, maybe let me try to make it. So it says me like there are some non-compliant items in my code, which shows like the policies S3 bucket lifecycle management, and I did recommend like to add the lifecycle rules for the S3 bucket to be created. And it also suggested some cost optimization opportunities and the compliant areas too. Like in this code, what we did is like we added the tags, right, which is the compliant. I mean, it's compliant with the FinOps principle, the standardization principle which they have defined. So we get a summary of this. So how did this happen? Like, let me show you. If you see, I didn't give a prompt also, I just gave the code, right? So here in the agent, I have defined somewhere like what it has to do once it got the code. Let me open it and show you. See here in the system messages, I have said clearly to the agent how it has to behave. Like I have mentioned, like you are a FinOps advisor to the TechCop, and your role is to review the whatever Terraform infrastructure code given to it and compare it with all the policies which are in the Pinecone vector DB. And also I have given some strict rules, which the main thing is like I want to avoid hallucinations or avoid the model to give me recommendations based on its pre-trained data. That's not something which we want. We want the model to behave exactly like my internal team member who has access to the knowledge bases or the FinOps principles which we define. So I have to give it a set of rules to exactly behave that way and not use any like pre-trained data. So those are the rules I have given additionally for this. And let me close this. And from the flow standpoint, if you observe, like first, the input goes to the agent, and then the prompt along with the code goes to the embedding model. The embedding model then chunks it, and then and that is used in the Pinecone vector store to do a semantic search and identify the relevant principles in the FinOps policies. And then again, that gets the context and the prompt gets augmented back to the reasoning model here, which then validates the code with the FinOps principles and then give us the feedback. So that's how this agent works. And coming to the vectorization workflow, so this is the vectorization workflow. So this workflow, it's a trigger, like I have already uploaded my principles in OneDrive, right? I'm sorry, Google Drive. So it downloads the file if I click it, if I execute this workflow, and then it has access to an embedding model too, along with a default data loader. So the file gets downloaded using this default data loader, gets downloaded here, and it gets uploaded using this default data loader. And then there is a text splitter which would chunk it, the file to the data, chunk the file, And then the embedding model helps to vectorize it and store it in the Pinecone vector store. And this is the Pinecone vector DB where we have these chunks after they are indexed. I'll just click on the workflow. There is no output to show here, but it just show you the flow actually. Yeah, it's already indexed, but I just clicked it again. In case if I have refreshed the file with some new principles, then if I click on this, it will update the latest vectors. So that's about this flow. Yeah, so how does this help actually, like, to save the cost, right? So now what we have done, in this agent, we have given our infrastructure as code, and before deployment itself, we are giving the feedback to the developer, like what are the principles they have to be compliant of as per the FinOps policies which they have defined within their organization. So by incorporating this feedback, the developers can adhere to their company rules and stick to within the boundaries which they are defined for. So nowadays we have a lot of vibe coders also, right, in any organization. So I mean, there is a high chance like it might generate a code which can lead to deploying some high configuration machines, which are only generally caught it after the deployment, after maybe a bill of 1 month or 2 months if they're tracking. So by reviewing the code with this agent, they get the feedback early, and that helps them to like modify things according to their organization standard. This principle like is called shift left in DevOps, where we try to give feedback early on to the developers. Like generally, the code is, if you recollect, like maybe most of the developers would be knowing, like the code will be added with security agents for security vulnerabilities, basically static code analysis or dynamic code analysis, right? Where you get the feedback early on before building actual builds. The same thing we are trying to do here too, like here but from the cost perspective, from the org principles perspective, like we are trying to give the feedback early on to the developers so that they can make the valid right choices. So yeah, that's the demo team.